All right. So now some parts of sequences that are actually calculus applications of them. And this is more of a preview for what we're going to be doing in Chapter 10 more than anything else. One thing that is very helpful is knowing how to graph a sequence on your calculator. Page 442 in your book goes over two different ways of doing this, one with parametrics and one with your calculator actually has a sequence graphing mode on it. And it goes through both. Parametrics, pretty straightforward explanations. Does a good job. On the sequence mode, if you're doing it on the TI-84, two things it doesn't tell you how to do are how to get the U and the N when you're inputting in your sequence to the Y equals menu. Uh, when you're in sequence mode on the TI-84, to get the U, you press second 7, and to get the N, it's actually going to be your X button that's next to the alpha button. Jasmine, I'll be happy to go over the TI Inspire and how to do it on with the TI Inspire if you have trouble doing it on your calculator. It's not hard on yours. It's just one I need to show you. But then what I want to discuss here are limits of a sequence. Uh, and what we're talking about here is converge and diverge. We say that a sequence converges if the limit as n approaches infinity of my sequence. In other words, as I keep doing infinite terms, does that limit exist? In other words, do my terms approach some number? Uh, it is important when doing these that all of our properties and theorems for limits apply here. You may want to go back to the chapter 2 things and remind yourself of those. This is including the sandwich theorem. It means L'Hopital's rule, which I already mentioned in the first video for this section. You may want to look over. Uh, there is one additional theorem. We're not going to use it very much right now, but come chapter 10, we're going to use this theorem a lot. Uh, it says if I'm doing the limit as n approaches infinity of the absolute value of a term, and that's 0, then the limit of the sequence as n approaches infinity must be 0 as well. And that's actually coming from the sandwich theorem. Uh, Now it has to be equal to 0 if we're doing this with the absolute value theorem, and that's why we don't use it much right now. But in chapter 10, we'll use it more. But remember, L'Hopital's rule will apply because we are doing limits as n approaches infinity, which is why, remember when we started using L'Hopital's rule. So to look at this, if I want to see if a sequence converges or diverges, and diverge just means that the limit wouldn't exist. There are several ways to do it. One would be algebraically. So this works very well in explicit form. So if I were looking for my limit as n approaches infinity of 2n minus 1 over n, uh, well, I'm going to infinity on top, infinity on bottom. I could do L'Hopital's rule. And so that would be the limit as n goes to infinity of 2 over 1, which is 2. So this does converge. Uh, Here, this is a little bit different in that this is oscillating because it depends on if n is even or odd. This part right here is approaching 1, but then this is going between 1 and negative 1. So I'm actually approaching two different things. So here, this actually diverges. And I know this part is 1 because of L'Hopital's rule, and I can doing the limit on that, because this would be the limit of this part times the limit of this. Well, the limit of this part goes between 1 and negative 1. It's just bouncing between them. So this limit does not exist for the entire sequence, so it diverges. Here, given a recursive sequence, recursive ones are tougher to do. One way to do it is to graph this, because if we graph on our calculators, it is done recursively. So if I could put this in for my calculator. Alternatively, I could change it into an explicit form. This is arithmetic because I'm adding 2 each time. So I could say that each term is my first term plus n minus 1 times my common difference of 2, which would be the same as 2n plus 2. And if I do the limit as n approaches infinity for my explicit form, well, I can see that goes to infinity, and so this also diverges.